So I want to spend the end of this video talking about some consequences of the existence of non-local games. It turns out, in fact, that non-local games are not just a mathematical curiosity, but they do have practical applications as well. So one of the most immediate consequences of non-local games is... So I want to spend the end of this video talking about some consequences of the existence of non-local games. It turns out, in fact, that non-local games are not just a mathematical curiosity, but they do have practical applications as well. So one of the most immediate practical consequences of non-local games is the existence of a test for quantumness. And let me explain what I mean by this. Suppose Charlie, a classical user, buys what is advertised as a quantum computer. Then at some point later, this supposed quantum computer is delivered to Charlie's living room. Now, Charlie is not an experimental physicist, he is just a regular user, so he's unable to verify the inner workings of the device that he bought. Basically, all that Charlie can do is press buttons on the keyboard and look at what happens on the screen. And so the question is there a way for Charlie to test that his device is doing something that is genuinely quantum, as opposed to being just a classical device in disguise? So how can Charlie, as a classical being, learn that the device is doing something truly quantum? And a solution to this conundrum exists if one makes just one extra assumption about the device, namely that the device consists of two non-communicating components. So under this assumption, Charlie can perform the following test for quantumness, which is inspired by what we have learned in this module. So Charlie probes the two components of the device with questions from a non-local game, like the CHSH game or the Magic Square game that we saw. Then Charlie gets answers in return from the two components. And Charlie then simply repeats this process many times and estimates the winning probability of the two components in the game. Now, if this estimate significantly exceeds the best classical winning probability, then Charlie is sort of statistically confident that the two components of the device were indeed sharing entanglement, a genuinely quantum resource. So this is a simple test for quantumness derived from a non-local game. And it turns out, in fact, that these ideas can actually be taken a step further to not only test that the device is doing something quantum, but to test that the device is performing precisely the requested quantum operations. But we won't get into this here. Now, you might wonder about how Charlie could be able to enforce this non-communication assumption in practice. Well, one way that Charlie can do this is the following. Charlie can make sure that the time that passes between the questions being asked and the answers being received is less than the time that it would take for light to travel from one component to the other. And to do this, Charlie would have to measure the distance between the two components. Now, since relativity tells us that information cannot travel faster than the speed of light, this implies that the components cannot possibly be communicating during the game.